Okay, we're going to talk about tricky combinations, and these are combinations that involve some constraint. So additional constraints can sometimes be hard to deal with. You have to use logic. So we're going to approach this from a logical standpoint, and if you want to approach this question on your own, go for it. I'm going to launch into it right now. So we have 7 members of a Spanish club, and we're asking if Jen and Tom are both in the club, so they're part of the 7 members here. What is the probability that both will be chosen to present a project? And there's 4 people that will be chosen to present it. Well, the probability is going to be groups that are Jen and Tom over total groups. So how many groups can be chosen that are just general groups with no rule? Well, if we have 4 people, we have 4 spots, and 7 people to choose from, 7, 6, 5, 4. Turn it into a combination by dividing by 4 factorial, the number of spots factorial. And this is equal to 4 times 3 factorial, and 3 factorial is equal to 6. So that's going to cancel a 6 and a 4, leaving us with 35 here. So there's 35 total groups. That's going to be the denominator. Now, how many groups are Jen and Tom in? That'll be the numerator, and that will give us the full fraction of what the probability is that the random groups that's chosen will be a Jen and Tom group. Well, if we lock Jen and Tom in, so Jen's here and Tom's here, as long as I can pair these two with another group of 2 people, we will have a Jen and Tom group. And how many people are left to choose from? Well, if we use Jen and Tom, there are only 5 people left of the 7. So I could really make a tiny group of 2 people from the remaining 5 people, which would look like this. Now, a lot of people will make a mistake and divide by 4 down here, but we actually want to divide by 2 factorial. We're treating it as its own tiny group. Because Jen and Tom are locked, they're their own group, and if we add to them a group of 2 more people, then we will have a total group that includes Jen, Tom, and any 2 other people from our original 7. And how many of these are there? Well, 2 times 1 goes into 4, leaving a 2. There's 10 of these. So there are 10 groups that Jen and Tom are both in, and that gives us 10 over 35, which divide top and bottom by 5 gives us 2 over 7. And this would be the probability as a fraction that Jen and Tom are both in the group together.